We recorded the simultaneous electromyographic activity of flexor and extensor hind limb muscles during walking in intact rats. We projected this activity onto the anatomical location of motor neurons in the spinal cord in order to visualize the spatiotemporal map of motor neuron activation during walking. These maps displayed a well-defined and reproducible spatial and temporal structure. To reproduce this motor neuron activation pattern after injury, we recorded hind limb kinematics in real time using a high-resolution motion capture system. The spatiotemporal trajectory of the hind limb endpoint resembles a clock that divulges the timing of gait. This movement feedback was used to trigger the activation of electrodes targeting extensor versus flexor hotspots. Rats received a complete spinal cord injury that led to hind limb paralysis. Delivery of serotoninergic replacement therapy and continuous neuromodulation applied over the midline of spinal segments enabled locomotion. However, the spatiotemporal map of motor neuron activation significantly differed from those recorded in intact rats. Spatiotemporal neuromodulation reproduced the map of motor neuron activation recorded in intact rats, which enhanced the vigor and extension and flexion components of both hind limbs. Increase in stimulation amplitude through the electrode targeting the extension hotspot led to the specific and gradual augmentation of hind limb extension on the stimulated side. The amplitude could be adjusted to promote optimal gait patterns. The same modulation was obtained when increasing the stimulation amplitude through the electrode targeting the flexion hotspot. In contrast, the same amplitude of stimulation delivered continuously, without temporal structure, blocked the hind limb on the stimulated side, while the contralateral hind limb kept on stepping.